Okay, there are 2 points we will take into the picture. One point P1, the other is P2. Theta is given 37 degrees. So let's have a this is the circular track O. For O we are discussing this problem. There's a point P. Yeah. There's a point C. This is O. The block will arrive here with a certain velocity at point P1. Here how much of velocity it should have to complete this track? Yeah. Now come for this. Here there's a point P2. What velocity it must have? I think if you can start from here, the velocity of this point, how much it should be? Root 5 gr to complete this circular track. There's a track. Smooth circular track. So to complete this track, the velocity at this particular point should be how much? Root 5 gr. For the velocity to be here, it will have velocity v1. Okay, this will take it x. Sorry, this is r, no? Radius is r. This is r. This is theta. R cos theta. How to get the velocity v1? I think look at this diagram. So here it will have velocity v1. So the block will move from A to point P1. Do we know the radius r? Yes, we know radius r. So applying conservation of mechanicity from point A to P1. Then from P1 to P2. Then we'll get the required answer. And at point P2, how much it should have the velocity? Root 5 gr.
Sir, the OC is smaller, sir, not the radius of smaller track, sir.
OC smaller, no? Oh. So that OC is equal to R. Yeah, I'll change this. Then we'll assume some other symbol. Radius of this will
R naught will take.
some A will take it. Let A be the radius of that. Okay, I made changes. OC equal to R, that one. What should be the smallest value of? Is asking the minimum value of R so that the block completes its turn about O. We know the total radius capital R. Shall we do one thing? First we know theta. I want the velocity at V1. Can I apply conservation of mechanism between A and P1? Yes, we can apply it.
Sir, that should be A cos theta.
A cos theta. Symbols, all I change it. Now one more triangle. Yesterday we are done, no? I remember yesterday somebody asked this. P1. Okay, this is theta. So what is the height it will descend? R cos theta. Here it will have velocity v1. It is released from here. No. Carry on now. Apply conservation of mechanism between point. Okay, this is not needed all. Okay, point P1, this should be the R. So first applying conservation of mechanical energy. So mg r cos theta should be equal to m v1 square by 2. So v1 equal to 2gr cos theta. 2gr. What is cos theta? Cos 37. Anybody value cos 37?
4 by 5, sir.
Go for this. This is the velocity of the bob at point P1. Now we'll apply conservation of mechanical energy between these two. Then it will be mv1 square by 2 plus mg a minus a cos theta equal to mv2 square. Now we know v2 root 5ga. Substitute that here, because it has to complete this track, means root 5ga should be the minimum velocity at the lowest point here. Substitute that v2 root 5ga from here, v1 substitute from here, then you're going to get a in terms of the required thing. M get cancelled, so v1 square equal to 2ga 1 minus cos theta v2 square. v1 square will be 8gr by 5. Komal Reddy, mute it. Just get on. Anybody value? We'll get A. From A we can get the OC. OC should be equal to R minus C. The problem will change if it is like this. If it gives track like this, the problem will change. If it gives track like this, no? I think we have to be very careful enough. Directly at this particular point, if the bob is having root 5gr, root 5ga, whatever that is there, no? I think it will complete vertical circular path, because it has to complete the loop here. So what is the velocity at this point? Should be equal to root 5g. What is the radius of this? Let it be a. Because this will be the lowest point of the track. Now the track is something like this. P2 is not this one. You can see that one here. I think you have to be very careful about how the small track is. Anybody value?
Sir, small a equal to 8 and small r equal to 15, sir.
OC value?
Sir, OC value is 15, sir.
15, sir.
15, 15 centimeter, 15 meter.